we'll start from the current slide. And let me start hitting the announcements. And apologize for how many there are, but it's a pretty busy week here. First place, okay, are any of you graduating this spring? You are, okay, not just walking this spring, graduating. You'll have your degree at the spring, okay? Have you seen the email about the scholarship opportunities at UAB and the scholarship opportunities at University of Alabama, Tuscaloosa? There are two of them out there, and they're pretty impressive. And so since you're the only one graduating so far, I'll leave them up here and you can take a look at them. Warning, the deadline for part of this is Monday, okay? I think you can get it all done. The second part of it is by March 1st, which is Thursday of next week, 1 week from today. So they are time sensitive. So if you want to see them, they're here. Okay. Also, let's see. I think I recognize her. I've seen her somewhere before. All right. Good morning. Jasmine's here. Okay. Also for graduates, and by the way, this is also if you know graduates. If you know someone who's finishing this term, tell them about their scholarship. Check their emails and the Lost State email that went to you. I'll be glad to share these with anybody. Here's the second thing for graduates, and share this with any of you may know. There are graduation meetings going on next Monday, next Tuesday, and next Wednesday. The one on Tuesday is here on this campus. The other two are on the Birmingham campus. The meeting on this campus will be Ethel Hall Auditorium. That's the newish looking building right across the parking lot. Go around the building and come in the main doors this way, and you're right there at the auditorium. That's 1:30 Tuesday afternoon. On the Birmingham campus, both of the meetings are in the ACAT building down on the first floor of the theater down there. And one on Monday is at 6 p.m. and the one on Wednesday is at 1:30 p.m. like the one here is. Okay? So please spread that word around where those graduation meetings are if you know someone who's graduating. Now that would pertain to anyone who's walking, not necessarily graduating, but graduated in the summer that is walking. They need to go to those meetings as well. Mr. Rossi is still looking for plenty of people to come and participate in the math team. Even if you don't want to participate in the competition, it's still a great fun time to do and helps you in math, okay? Now, this afternoon at 2 to 3:45, we have some technical training going on. And I'm going to go down there, and if the room's not packed, I'll probably stay for the training. If it is packed, I figure these younger folks need it more than I will, because I'm not going to be here as long as they are. So anyway, that's 2 to 3:45 this afternoon. If you can't find me in my office, that's probably where I am. Okay? So just let you know that. I think I announced to you before the tutoring schedules on both campuses. I've got them up here. Down the hall here in Student Support Services, you can sign up for tutoring just about any time of day. I'm sure at midnight they're not going to have anyone, but any time the school's open, if they can find the tutor, they'll arrange it for you. Okay? Downstairs in the Space Center, we're only limited to Monday and Tuesday right now. If they can get more tutors in, and some of you seem like you would be great tutors in math, 090, 098, and 100. So if you'd like to participate as a tutor, check with either Ms. Hollins up here in Student Support Center, or I can't think of the gentleman's name down in the Space Center, but Dr. Davis is also coordinating that. However, Dr. Davis will not be on campus. She's the academic dean tomorrow because she's flying to Maryland. There's a funeral for an aunt on Saturday, and she has to fly tomorrow. Okay. Now, on the Birmingham campus, the Space Center has got tutoring 5 days a week. And by the way, both places, the tutoring is free. Okay? And also on the Birmingham campus, in addition to SSS for developmental students, there's also the STEM lab that provides tutoring. I don't know the hours for that. That wasn't included here. But there's tutoring every day of the week, Monday through Friday, at the Space Center on the Birmingham campus. Okay? This is homecoming week. Okay? That's what's part of making this along. Today, there's a cookout. Okay? Starting at 11 o'clock, but going through the whole lunch hour. So even if you have 11 o'clock class, don't miss the class. You can get to it at 12:15. There'll still be food. Okay? And that will be on both campuses. So if you happen to be over on the Birmingham campus, it will be near the Leon Kennedy Center, I think. Okay? I know on this campus, it's going to be that lower level down there between the A building and the B building, right near the library. That's where the cookout will be. Okay? There may be some things up on the upper level where the student services interest is, but most of it will be down below, just down that flight of stairs. So that starts at 11 today, but it'll go through the whole lunch hour. Then this evening, 5:30 this evening, speaking of Cougar Choices, it's the Cougar Choice Awards, and that's in the A.G. Gaston Auditorium. That's on the Birmingham East Campus. Okay, sorry about that. Okay. All right. So that will be their Cougar Choice Awards, Birmingham East Campus. Tomorrow, okay, back to the 90s is the theme. You don't have to do this, but it makes it sort of fun. And they have several of the sitcom TV shows that were present in the 90s. If you want to dress up like some of the characters in those or just anything from the 90s, that's perfectly fine. Y'all were born in the 90s. No, I won't even ask that. Okay. Now, the main thing they have here is Party with a Purpose. Okay? And what's the purpose? Bring some items for a shelter. Okay? You can bring blankets, non-perishable items, as in non-perishable food items, toiletry items, anything that would be useful at a shelter. Bring that. The admission is free if you bring your that. So there's the purpose. The party goes from 7 till 9 in the Leon Kennedy Center on the Birmingham West Campus. That's where the cafeteria is. In fact, it's in the cafeteria area, Birmingham West Campus. The next Monday is Game Day Monday. That's when the homecoming parade will be. That starts on the Birmingham East Campus. They'll close the streets. The parade will start at 4 o'clock in the afternoon, go from the gazebo there, wherever that is. I think it's near A.G. Gaston building. Okay, and then the parade will go across the street to near the gym, I think, or Leon Kennedy, somewhere there. And to the gym. Okay, and that will be at 4 o'clock. Then at 5:30, the women play. Women's basketball team, homecoming game. That's at 5:30. They're playing Gadsden State. And I assume the men will play afterwards at 7:30? Okay. That got cut off down here, or they didn't care about the men. I don't know. But anyway, that will be at the Arthur Shores Fine Arts Building, which is also the gymnasium. So, Birmingham West Campus. All right. Okay, one more. Okay. And this is just for information. Like I said, today I have a training meeting down the hall here from 2 to 3:45. Next Thursday, why they've started hitting Thursday so badly, we have a dean's meeting and department chair's meeting over in the Ethel Hall Auditorium, so it'll be on this campus from 2 till 5. Ugh. Okay. No, I'm sorry. I didn't say that, did I? Not out loud. Okay. Well, they don't say till 5 here, but I saw it on an earlier email. Hopefully they'll let us go earlier. Sorry about that. Now, let me catch up on the people who came in. Janisha, okay. Don't want to miss anybody. I know I hadn't gotten down to it, but Jayla wants her name marked, so I'll get that, okay. Okay. find you. You're hiding, aren't you, Gavin, right? Okay, there you are. And anybody else come? Oh, yes, I'm sorry. Huh? Kelsey, got it. Okay, I just saw your name. I forgot the name. Okay, Kelsey. Anyone else come in since I called roll? Okay. All right. Any questions? Sorry about taking so much time for announcements. Okay. Either campus type questions or, and by the way, since several people did come in, are any of you who came in graduating this term? Okay, or walking this term but graduating in summer? Okay, it's not, yeah. Oh, you are. Okay, I thought you were. Okay, there's 2 scholarship opportunities that came to your email. Did you see them? UAB and University of Alabama, Tuscaloosa. And those deadlines are really soon. Monday is the first part of the deadline, and Thursday is the second part. Okay, and also the 3 meetings for graduation. Yeah, 1 on this campus and 2 on the Birmingham. Next week. Okay. And spread it around. If any of you know people who are graduating, make sure they know about all of those. All right. All right, why am I not finding this? Where is my mark? Okay, did we do, I think we did, the first 2 parts. Oh, I know why it is. I didn't make my mark. I think we did all of example 5, didn't we? We started example 6? Okay, that's what I was thinking. They left off example 6. And the PowerPoint. So that's why I was at that place. But I forgot to put my mark up here. All right. Oh, yeah. Okay. Find the domain of, let me get my pen activated. Okay. Find the domain of F composed with G for the functions f of x is equal to x squared minus 9 and g of x is equal to square root of 9 minus x squared. That's example 6. Did we already do that? No, but we started it. Is that right? Okay. Was 5C, and we finished it, right? Yeah. They don't have the slide for 6, so that's why I'm using this slide. Yeah. Okay. Now, I don't know exactly where to begin here. Well, the problem says find the domains, okay? So, the best place to start is what's the domain of the individual function? So can someone tell me here, what's the domain of f of x? Say again? Yeah, what's the domain of that? What are acceptable values you can put in there? Say again? All real numbers, exactly. That's a polynomial function. No question. All real numbers. Okay. Now, second part, what's the domain of g of x? I think we did get started on this because I remember we talked about that. What's the domain of g of x? And if you don't know it right off looking at it, how could you find it? What statements can you make with great certainty about g of x? What warning sign? Say again?
All real numbers except -9.
Okay. I will agree that both of those won't work, but I would contend to you they're not the only ones. Yeah, if you put a -9 in here, that would be -9 squared would be 81, positive 81. 9 minus 81 is extraordinarily negative, and that you can't take the square root of it. Put a positive 9 in there, same deal. Square 9, you get 81. 9 minus 81 is -72. Can't take the square root of that. But I would say these aren't the only two, okay? There are plenty of others that you can't have in your domain. What can you have in your domain? What has to be true? What's the warning sign? Say again?
Has to be positive.
What has to be positive? CJ has to be positive, doesn't he? Yes, okay. Okay, let me get him marked. While y'all are thinking about it. No, you have to be present. That's it. Not positive. Okay. Now, what were you saying? What has to be positive?
Well, he had just said that the coefficient inside the square root has to be
Okay, yeah. Whatever is inside the square root sign, that's the key. The square root sign is a red flag that says, hey, look at me, okay? Anything inside the square root sign or any even root, if that radical had an 8 up there in the little crook, that would be, well, oh, my goodness, I believe Chris is here. Okay. Does anyone else come in since the called roll? Okay? Anytime you see a square root, it screams at you, what's inside of me has to be positive. Okay, so that's what I thought you were getting at there. So we can say here, 9 minus x squared. Now, how do we express that as got to be positive? Okay, Brianna is here. Okay, she's positive. Okay, good deal. How do we express that?
greater than
A little louder. Okay.
greater than or equal to?
What? Greater than or equal to is the correct sign. 0! Exactly. It's got to be positive. It can't be negative. So it's got to be greater than 0. Now we can solve that inequality, can't we? How do we solve that?
Minus 9 on both sides.
Second?
Minus 9 on both sides.
Okay. You can do that. It's a tad slightly risky. So if that were an equal sign there, how would you go about solving that if that was an equal sign? What's your F word? Factor! Okay? Let's factor that. Anything that's a quadratic or higher, see if you can factor it first. Is that factorable? Still greater than or equal to 0. How does that factor? Say a little louder?
X plus 3x minus 3.
Okay, I'm going to write it as 3 minus x times 3 plus x. It actually will give you almost the same answer, but not quite. But you square root of this plus or minus the square root of that. Okay? That's the safest way to go. Now, what does this represent? These two parentheses written next to each other.
4.
Say again? Yeah, we get back to that. We don't want to do that here. But what does that represent? What are you doing when you're falling? What operation? Multiplication, exactly. Now, what happens if you multiply two entities and you're talking about whether they're positive or negative? What are some rules there? In other words, what must be true of these two entities for that to be positive? Greater than or equal to 0. Okay. He jumped right to the meat of it right there. Okay? What I was getting at, and we're going to get back to what you just said, for two things multiplied together to be positive, either one of two cases has to be true. Both of them positive or both of them negative. Exactly. If they're different signs, that's not going to be true. So we have a condition here, two possibilities. Either 3 minus x is greater than or equal to 0, and 3 plus x is greater than or equal to 0. Or, okay, there's the and, here's the or, 3 minus x is less than or equal to 0, and 3 plus x is less than or equal to 0. Okay, I know it's a lot of mess here, but what would we do to solve these inequalities? Okay. Well, I think I heard you say was subtract 3 from both sides. Okay. Minus 3 minus 3, and we're going to do the same thing here, minus 3 and minus 3. And guess what, folks? We're going to do the same thing down here, minus 3 and minus 3 and minus 3 and minus 3. Okay, we're going to subtract 3 from both sides of all those inequalities. I just went on and wrote them down. What does the first one give you? Negative x is greater than or equal to negative 3. This one gives you x is greater than or equal to negative 3. This one would be negative x is less than or equal to negative 3. And this one would be x is less than or equal to negative 3. And by the way, the and stay here and the and stays there. Okay. So let's hit this one first. What's your next step here? So again, divide by negative 1. Okay, and what happens when you divide an expression like that by negative 1? The signs change on both of them. So that would become an x, and that becomes a 3. Anything else happen? Yes, your directional inequality flips. That happens anytime you multiply or divide by a negative number. Doesn't change if you add or subtract positive or negative numbers. Doesn't change if you multiply or divide by positive numbers. It only changes, but it always changes when you multiply or divide by a negative number. So that becomes this one. Okay, now that or is for here. So I'm going to get that or out of the way here because I need the and in there. Okay. Okay. So and this one's already there. X has to be greater than or equal to negative 3. Okay? So what we're going to do here, I'm going to draw me a number line up here. Okay? Good old number line. Here's a 0, 1, 2, 3, 4, 5, 6, and negative 1, 2, 3, 4, 5. Okay, whatever. Now, can you tell me how to draw on that number line this expression here? X has to be less than or equal to, and I lost my minus sign, didn't I? Negative 3. I can't get it to write. No wonder. Okay. There it is. X is less than or equal to negative 3. Wait, no, that was a plus sign. What are you doing? You're messing me up, aren't you? Okay. Okay, that's a plus 3. Only it's not writing. Okay, because we divided both sides by minus 1, and that made it a plus 1. Okay, trying to mess me up. So how would you express this? X is less than or equal to 3 on that number line. Okay, there's 0, 1, 2, and 3. A dot on 3, and we'll close it in. Why do I close in that dot? Because it's equal to. If that was just strictly less than, it'd be an open dot. Okay? And which way do we go from there? Yes, towards 0, and it goes forever. Anything on this side of that dot is less than or equal to 3. Right? All right, let's do the next one. That has to be true because the and is in there. X has to be greater than or equal to negative 3. So how would I go there? Go left to negative 3, and what do I put there? A dot, okay? And what are things that are greater than or equal to negative 3? Everything to the right, okay? Now what we have to do is do both of them. They both have to be true. The and has to be there. That gives you the domain for that function, right? Okay, so now we've got the domain for this. We're just got started. Okay. Now let's do this one down here. Oh, we didn't finish that, did we? Okay. So what's the next step on this one? Yeah, divide by negative 1 or multiply by negative 1. That works too. What would that give you? X 3. And we swapped the sign because we multiplied or divided by a negative 1 and got Monica here. Okay. We should have done that soon. Okay, no, I got it. Okay. Now, boy, what a messy number line y'all draw. Okay, I'm going to erase that number line for now, or at least parts of the number line. Let's see how much I can get rid of without damaging things. Get rid of that and that. And wow. I did it. Look at that. Okay. Now, let's do the first one down here. How would you plot on here x is greater than or equal to 3? Dot on 3, got it. And then it's what? Everything to the right. Okay? So I did forget one thing here. Should take that off. Okay? So everything to the right would be here. There's the domain of the first one. How about the second one? X is less than or equal to negative 3. Go down to negative 3, which is there. Everything to the left of that. Now, what's the domain? And remember, the and is in here. Okay? So both have to be true. What's that domain? The empty set. It can't be positive and it can't be negative at the same time. Okay? This says it has to be greater than or equal to positive 3. This says it has to be less than or equal to negative 3. You can't have them both. There's no number that fits both of those requirements at the same time. There was a bunch that did that one, and I should have written it down. So our domain here is negative 3 to 3. And that's what you were thinking before, right? Right. Yes, I thought so. Okay. Now, let's get to this thing. This is F composed with G. What in the world does that mean? Remember that rule? Yeah, I know it was a long time ago. Tuesday, okay. What does it mean? F of G of X. Okay. Now, where would we begin if we were going to try to evaluate that? The innermost. We would start with G. So we start with this domain. There it is, right up there. Negative 3 to 3. Okay, now that's going to give us an output, isn't it? And that number, when x is negative 3, you're going to have 0. And when it's positive 3, you'll have 0. When it's 0, you're going to have 3. So it's going to go everything between 0 and 0 and 3. Okay, basically it's going to be half a circle. That's going to be your output. Okay, from 0 to positive 3. This good old L function will take all real numbers, remember? So yeah, we're happy with those. That's your domain. Negative 3 to positive 3. Now, it's not asking you to calculate what this is. We could, but it's asking what the domain is. Okay? But guess what? They turned around and did it anyway. So let's do it. Okay? What do we mean by f of g of x then? How would we evaluate that? What do we put in first? Okay? If you're doing f of g of x, what do you put in first? The innermost part, the g. So that'd be f of, and what's g? The square root of 9 minus x squared. Now, what do you do with that? The f function tells you to do what? Take whatever is in the parentheses and square it. What's in your parentheses here? Square root of 9 minus x squared. And if then we take that and square it, what does that become? Say again? The square root goes away, okay. And you just have 9 minus x squared, because when you square a square root, you lose the square root. And then you after you square the thing, you Subtract 9 from it. Very good. How did you see that? Okay. And what does that give you? Negative x squared. Okay? Now, if you had started with this and worked through this, and then you ask yourself, what's the domain of this? What does it look like that would be? All real numbers. But it's not, because you have to go through that to get to this. And you can't put all real numbers in there. You have to only put numbers between -3 and 3 in there. Otherwise, it doesn't make sense. So the domain of this is not all real numbers. It's -3 to 3 for this problem. Because you can't turn around and say, it's sort of like saying, all right, in order to win this prize, I need everybody 18 years of older, okay? And then we're blah, blah, blah. Well, I'll let y'all join too, you know. No, wait. You can't then let a 16-year-old come in and say, oh, I won the prize. No, the original rule was that, even though after you manipulate it, you said, okay, it looks like it's anybody, okay? No, it's not, okay? So I don't know. I tried to get so all of you would win, but never mind. You lost. You're in my class, okay? Any questions on that? All right. I think we also have an example. Let's see what else we have here. I think there's something printed. Yes, here it is. In examples 5 and 6, you form the composition of two given functions. Okay? We didn't have to on 6, but we did. I mean, the book did. In calculus, it's also important to be able to identify two functions that make up a composite function. Okay? So, therefore, we have what we call, here's an example. Here's an h of x, that's a function of x, and it's made up of this, 3x minus 5 cubed. What is that? It's a composite of two different functions. What's the outer function? Which we usually call f. The cubic function. What's the inner function? Which we usually call g. The linear function, 3x minus 5. That's it. So recognize that is indeed a composite of two functions. The outer one being the cubic function, the inner one being the linear function, 3x minus 5. Okay. Now you might say, so, I mean, what's the deal here? Well, the deal is in calculus, which I hope some of you will continue to do. I know Melba is. Good deal. Okay. All right. It leads to, when you're taking derivatives and stuff like that, you get to the chain rule. And you need to recognize what a composite function is with the chain rule. But we'll get there. So like you said, like we were just saying, the outermost function, f of x, is the cubic function. The innermost function is the innermost function, 3x minus 5. Okay? So you could write h of x as g of x cubed, which is f of g of x, right? Because f is the cubic function. See it? All right. So, why are we doing this? So basically, sometimes we want to decompose a function, a composite function. You look for the inner function, and that's usually pretty clear because it's inside something, and then look for the outer function, and that's pretty clear because whatever is happening is outside of that. So in the function h, the g of x was the innermost, and the outer thing, that cube outside, that was your outer function. Sort of makes sense, doesn't it? Okay. Let's do, whoa, they skipped example 7. Shame on them. Okay. So let's do example 7. Write the function h of x is equal to 1 over x minus 2 squared as a composition of two functions. And let me just tell you, there are at least 2 different ways to do this. So you pick any one of them. Okay? If you're looking for the composition of two functions, it might be a good idea to write down what you think those functions might be. One of them let's call f, because they always did, and the other let's call g, because that's what they usually called it. You could name them anything you wanted to, just not h. That would be confusing. So which one you want to name first? You want to name alpha of x first? What do you want to name it? I mean, that's the name. What do you want it to be? Frankly, I like to start with the G because it's easier. I'm just lazy. Okay. What seems to be the innermost function there? Okay, now that's one way to approach it. He said x minus 2 squared. And that's a perfectly good way to do it. Then what would your alpha be? Alpha of x be 1 over x. 1 over x, or x to the minus 1. Because what you're doing with that, f of g of x would be f of 1 over this thing, g of x. That's one way to do the problem. That's perfectly legal. Okay? Here's another way. Want me to do it in a different color? Pick a color. Red? Is that what I heard? Okay, we'll do red. Okay, you could have chosen the g of x to be x minus 2. Then your alpha of x would have been what? 1 over x squared. You got it. Okay, you got the idea of it. Whatever this is, you plug it into f and you should get that. So either one of those have been perfectly correct answers. Okay? And that's called the decomposition of two functions. And by the way, I haven't said this every time, every one of these examples has a checkpoint, and if you get stuck up on the checkpoint, go to larsonprecalculus.com and you can see audio video solution to it. Now, since we're talking about the decomposition of two functions, do you want to hear a dumb story? Yeah. Okay, you do? Okay. And, I mean, it's not all that dumb, I guess, but yes, it will be. Okay. Any of you ever heard of Beethoven? I don't mean that big dog. Okay, that's a different story. Okay. Okay. One of the greatest, and Miss Shelton just next door, she would probably agree with this, one of the greatest composers who ever lived. I mean, his Fifth Symphony, da-da-da-da, you hear it played all the time. Just fantastic, incredible piece of music. And they say that everybody today plays it way too slow. He really fired it in there. And it's a fast piece anyway, the way we play it. So it must have been incredible to hear. And he was basically pretty close to the top of the field, you know. But you know, in music, can anyone name who won the Grammy 5 years ago? Probably not, okay? Because the artists change so frequently, styles change so frequently, and unfortunately, even though he was one of the greatest composers of all time, people sort of got tired of big symphonies and wanted something lighter, you know, or something different, you know. So their taste changed and they moved off to other things. And Beethoven was having a hard time making it, and he was getting older. I know the feeling. Okay, well, there was no Social Security back there, no blanket, they call it, to catch people that fell through the crack. He was having a harder time living, really. And on top of that, he started going deaf. Now, composer of music to go deaf, not a great combination there, right? And you know what? I've heard this before. I think it's true. What he did was cut the leg. He composed on the piano, and he cut the legs off of his piano so it sat flat on the floor. He sat flat on the floor and composed there. And what he couldn't hear, he felt. And he was that attuned to music that he continued writing symphonies. He was having a hard time selling them, but he continued writing them. But his health, Charles Barkley says, Father Time never loses, okay? And over time, his health continued to deteriorate. He continued to deteriorate. But by then, he was poor, destitute, and he died a pauper. And no one even noticed, okay? And I don't think he had any close relatives. I don't think he ever married. And so they just took him to what they called the Potter's Field, you know, the place where they buried poor people, you know, that didn't have any extra health care. And they buried him there. They kept moderate records of it and stuff. A few years later, I don't know how much later, but sometime later, people started saying, all this light little music, it's fun, it's good, but it doesn't hold a candle to Beethoven. Whatever happened to Beethoven? Okay? And so they started looking around and found out he'd already died. Penniless. And was buried in the potter's field. And they said, this isn't right. Listen to his music. It's the best stuff we've ever heard, really, or really close to it. We've got to honor this man. So let's get him out of the potter's field and put him in the central cemetery and have a mausoleum there and have it there so people can recognize and acknowledge what a great man he was. So they had to go through all the legal ramifications to dig up the grave and get it up and move it into the new cemetery. And they finally got all the paperwork done and finally got it done. And then they exhumed this grave, and they were dog tired by this time. And they got it up, and someone dropped it. Okay? And the lid flew up. And there he sat, erasing chords of sheet music like this, like crazy. What was he doing? Decomposing. Okay. I told you it was a dumb story, didn't I? Okay. Enough of that. All right. Okay. Y'all are wasting time, aren't you? Okay. Let's get on to applications. Okay? This is a pretty real-life type model here. Okay? You can represent approximately, understandably, the number of bacteria, which we're going to call capital N, in a refrigerated food is given by N of T. Now this capital T, if you see a little t, usually that's time. If you see a capital T, usually that's temperature. Okay? So N as a function of temperature, the number of bacteria as a function of temperature is 20T squared minus 80T plus 500. Now when it says a refrigerated food, when I first read the problem, I said, what do they talk about here? What they mean is it's been in the fridge. Okay? You pull it out and set it on the table, that's when the clock starts, basically. The function, number of bacteria as a function of temperature is this, as long as the temperature is between 2 and 14 degrees, and by the way, that's degrees Celsius. Okay, now what does tell me approximately what 2 degrees Celsius is. Anyone know?
35.
Okay, very good, very good. About 35 degrees. It's a little above freezing, okay? Because your refrigerator, you don't want your food to freeze, so it's a little above freezing, okay? You pull it out of the refrigerator, and the temperature is at about 2 degrees. And it sits on the counter there and slowly rises to around 14 degrees. Because, does anyone know what normal room temperature is in Celsius? About 20. 20 degrees Celsius is 68 Fahrenheit. Okay? So, this is not quite up to room temperature yet, but as it's warming up, what happens? What do bacteria do when they're cold? Some of them don't die, especially if it's not below freezing, but they don't multiply very quickly. Okay? It's only when they start warming up they get to be active. Okay? And then they start growing. So the number depends on the temperature. When you first pull it out of the fridge at 2 degrees, you can calculate and see how many bacteria you would have. And then when it gets up to 14, we'll see. So where T is the temperature in degrees Celsius, when the food is removed from the refrigeration, the temperature of the given food is given this way. Now here's your capital T is standing for what? Temperature in Celsius. Little t stood for? Time. Okay? Now here's another equation from physics. Okay? This is more from biology. This is from physics. That the temperature as a function of time is 4t plus 2. Now T is the number of hours. Okay? So when you first pull it out of the fridge, what's your temperature? When T is equal to 0. 2 degrees Celsius. Yeah, that's what it was when you first pulled it out. And then after 1 hour, what would be your temperature? 1 hour would be, what did you say? 6. Okay, I thought you said that. Okay, 6 degrees Celsius. 2 hours later, it would be, 2 hours after you pulled it out. 10. 3 hours after you pulled it out. 14, and that gets you up to 14. Now, we're not going past 14 because probably by that time the microbes are just growing like crazy, bacteria. Okay. So let's just stay within these, which keeps us within that, right? Okay. So find the composition of the function n composed with t of time, little t, and interpret its meaning. So they didn't leave me a lot of room to write here. So what would be this n composed with t? Why did I? Oh yeah, I know why. What does that mean? Give me that definition. N composed with t. Help me, help me. N of t of t. Okay, got it. Okay. Now, given those functions, what do I plug in first? Little t. Capital T of little t, okay? So that would be n of 4t plus 2. Okay? Now, what would we do next? What does the n function do? Starts with 20. So we'll start with 20. And then what does it do with that? Take your t, which is 4t plus 2, 4t plus 2, and does what to it? Squares it. And then what? Subtracts 80 times 4t plus 2. I can't write. Okay. Okay. And then what? Adds 500 to it. Okay. Well, we got a little work to do now, don't we? Can I move this up here? Okay, we're going to take this and move it up here. Okay, that would be 20 times. Can you do 4t plus 2 squared? Okay, say it a little bit louder. Okay, how'd you get the 8t?
Oh, 8.
Say again?
8 plus 4.
8 plus 4? 6? No, 12? I don't think that's it. What does this mean? 4t plus 2 squared means 4t plus 2 times 4t plus 2. And I think earlier you were telling me you foiled that, didn't you? So let's foil it. What do you get? 16t squared. There's your plus 8t. But then you got another 8t. And then you have a plus 4. So that would add to 16t squared plus 16t plus 4. Okay? Now that's the long way to do it, and it's always fair to do it that way. It's perfectly fine. The shorter way would be square the first. Square 4, you get 16. Square 2, you get t squared. 16t squared. Twice the product of the 2. The product of the 2 is 8t. Double that, you get 16t. And then square the last plus 2. Okay? If you're lazy, that's how to do it. If you're a hard worker, you can do it the other way. Okay? But get it right, either way. Next, this one we can multiply through. What does that give us? big numbers, down here,
By 20,
minus what?
you said multiply,
Distribute the 80 across that parentheses. Negative 320, right? T plus, say again?
320,
I think it's 160, isn't it?
320T,
80 times 2 is, and it's a minus, by the way,
160.
160, yeah, and it's a minus 160. Watch those signs, they sneak up and bite you, okay? 160, and then we have a plus 500. But we still got to distribute the 20, and I'm basically running out of room, so let's come down here with it now and see if we can get it in here. 20 times 16. Ooh, boy, what's that? 320, is that right? I heard? 320 T squared. Say again? Plus 320 T plus 80 minus 320T minus 160 plus 500. Whew. Okay. They're getting the money's worth out of this problem, aren't they? Now, what can you do next? Where is that? Oh, yeah, 80. Oh, yeah. Who left off the 0? Okay, you lose points. Okay. What can we do with that now? Combine like terms. What like terms do you see? Well, I don't see anything like 320T squared, so let's leave that one alone. 320T squared, that's the only T squared terms you got. But 320T minus 320T is 0. We got that one done. And then what other like terms you see? Okay, you add these two, you get 580, subtract 160 from it, and you get, and that's a plus 420, right? All right, there is your N of T of T. There it is, right there. Okay, we've written it. We found it. There it is. Okay. Interpret its meaning in context. What does this tell me? What does N stand for? Now this is, here it is. That's this thing right here. It's N of little t. What does N stand for? Number of bacteria. So this is number of bacteria as a function of little t, which was time. So this is how many bacteria you have in that turkey carcass that you pulled out of the fridge, and started to eat. When you first pulled it out at time, and this T goes from 0, when you first pulled it out of the fridge, had 420 bacteria. That may sound like a lot, but believe me, it's not very many. But let's wait. How many hours you want to wait before you put it back up? 2 hours? Is that what you said? Or 3? Huh? 6. No, you can't do 6.
Oh, yeah.
It'll be eaten up and green by then. It'll be
Two.
Huh?
2.
2 will work. Okay? So let's take 2 and square it. And, yeah, 4. 4 times 320. 1280. This calculator is slow. 1280 plus 420. 1700. 1700 bacteria. Okay, it went from 420 bacteria to 1720. It's 1700 bacteria. Let's put that back a little sooner, okay? All right. Because those bacteria are growing like weeds, okay? Only worse. So that's how we interpret it. It's the number of bacteria as a function of time. Okay. Now, next question. Find the time when the bacteria count reaches 2,000. How can we do that? Is it all right for me to erase some stuff here because the screen is awfully crowded? Is that going to be okay? Okay, let me erase these. And let me get some of the marks off here because that makes it hard to read. I don't think I need that anymore. Or that. Or that. I know watching this at home is fun when this starts disappearing. Okay, and that. Okay. So here is your n of t. Little time t. Little t time t. Okay? Now, it's saying find the time, which will be little t, when the bacteria count reaches 2,000. What's the bacteria count? N. All right, well then we'll take this one right here and say 320 t, we're looking for the t, okay, squared, plus 420, is that all 20s there? I guess right, okay, is equal to 2,000. What can we do with that? Second? Okay, now if that were a t there, that would be how I would do. But see, that's a t squared. Okay, now that really does sound like a pretty good idea. First thing I would do, though, when you have a quadratic, let's move everything to one side and have 0 on the other side. But I might be doing my hands wrong. Okay, because then you can see if you can factor. And that's what you're doing by dividing. So let's subtract 2,000 from both sides. If that was a single t there, yeah, subtract 420. But now we've got something bigger, 2,000. And that will give us 320t squared minus, is that 1580? 1580 is equal to 0. Now, I liked your idea, or someone said it. Divide by 320. Let's try that and see what happens. Okay. So that will give me a t squared. I can do the first part, okay, minus, if someone's got a calculator, actually you can get rid of the zeros, 158 divided by 32. 1580 by 320 or 158 by 32. It doesn't matter. I'll just divide it by 10. Make it easier, shorter, quicker. Say again? 4.93, is that what you said? Okay. Now, actually, I'm beginning to like Brianna's idea better all the time. If we had just put that on the other side, this is equal to 0, we said t squared is equal to 4.93. That's what you were going for, wasn't it? Okay? That would have been okay, too. And what can we do now? Take the square root of both sides. Now, a lot of times that's a dangerous thing to do because people forget to do the plus or minus, right? Right? But here, is time ever going to be negative? No! So we don't have to worry about that. So yeah, let's just take a square root of that and see what we get. You got it on your calculator? Just take a square root of it. Anybody? These calculators are slow, aren't they? 2.62, is that what you said? Huh? 22? 2.22? Okay, is it 2.22222222? Okay, say that one more time, I can't hear. Okay, 2.22, let's just stop there. And that will be hours, right? That's what T is measured in. You got it? Okay, now, I'm not used to thinking in 2.22 hours. I usually think in hours and minutes. So how do we change the 0.22 to minutes? How many minutes are in an hour? 60. So why don't we do 60 times 0.22? Well, the 0 goes away, and that gives you 2 that would be about 13 minutes, right? I think that's right. So that'd be about 2 hours and 13 minutes. 2 hours and 13 minutes, you got 2,000 bacteria living in that turkey carcass, okay? You're going to put it up and throw it away. You know, don't leave it out there too long, okay? It can really explode. Okay. Most of the time it's okay, but yeah. Let's see what they got. The 2.2 hour, they just left it as 2.2 hours. I don't know. Okay. Is that Beethoven? No, okay. All right. We throw away the minus solution there because who cares? Okay. All right. There is a checkpoint, another real good one to take a look at. Let's do vocabulary. And she closed the door on me. Okay, never mind. All right. Two functions, f and g, can be combined by arithmetic operations of blank, 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 and blank to create new functions. What's our 4 arithmetic operations? Addition, subtraction, multiplication, division, sum, difference, products, and quotients. Yes, all those would be fine. Number 2, the blank of a function, f, with the function g, is f with a little circle g of x, which means f of g of x. What do we call that? Composition. Okay, very good. Homework exercises here. Do number 3. Now that's strictly graphically. That's a little bit different from what we've been doing, so see if you can. If you can't, CalcChat.com has a tutorial help, a worked out solution for number 3. And if you still can't figure it out, see me. Ask it in class and we'll take care of it. Then do any of the odds, 5 through 11. All those odds are at CalcChat.com, 11's at CalcView.com. Do any of the odds, 13 to 23. All those odds are at CalcChat, 13's at CalcView. Do either 25 or 27. Both of them are at CalcChat, 25's at CalcView. Do any of the odds 29 to 33. They're all at CalcChat, 33's at CalcView. Do any of the odds 35 to 41. They're all at CalcChat, 35's at CalcView. Do number 43. It's at CalcChat. They don't have that on CalcView. Then do either 45 or 47. They're both at CalcChat, but 45's at CalcView. Do any of the odds 49 to 55. All of those are at CalcChat, only 49's at CalcView. And then do at least one of the word problems, 57 through 63. Okay? Whichever one you're most interested in, stopping distances, vital statistics, geometry, or your salary. No one's interested in that. Okay, never mind. Okay, and then, too bad the pets aren't there. That's a big picture. You can think through 65. That's just a true-false. Figure out why it's true or false. Then there's another pretty good problem, 67. 69's a proof. If you're interested in doing those, that would be fine. Writing functions is 71, and there's another proof at 73. And next time we will start with 1.9. Okay? Now, 1.9 is the last section that we're going to cover, which means that after 1.9 we're going to have our test, which means I need to have the quizzes in before you take your test, because I want to give the quizzes back to you, but I can't give them back until I get them all in. I'd like for you to be able to study them, so please get the quizzes into me sooner rather than later. Okay, and if any of you need to see your quizzes, I'll be glad to show them to you, but I just have to keep them until I get them all in.